Hello everyone. Is there anyone who has joined yet? No. So let's wait. Hi, Rohit.
Sorry for the delay. I was in office meeting.
No problem. Uh, can you see my screen?
Yes.
Yeah. Okay. Okay. Give me 1 minute. I'm not sure if Saransh is going to join, so let's make it a start. Yeah? Okay. So until the last session, what we have done is we have looked into the basic implementations, right? So we did this basic multiple linear regression implementation with the stats model package because we wanted to look at the tabular output, right? So that we can understand R square, P value, and so on, right? So from this table, we understood what all are the respective P values for each and every variable, and we could clearly see which one is really positively impacting or which one is doing a negative impact if there are any. And then we could also create this formula, right? From the coefficients and the intercept that we got, we could create this formula. And we could also do the estimations, right? We also looked into the fact that the moment we do this is where we add the newspaper, the newspaper related aspects. The number of items that we estimated for sale is actually going down, right? That's actually something which we don't want. So that's why, in a very mediocre sense, what I can write over here is maybe something like this: is basis the above two models, uh, we see that the one without taking into consideration the newspaper ad means is yielding bit more value in terms of sales quantity, of course, sales quantity of our product. Hence, we can recommend that investments only in TV and radio has some good impact as a combination, I can say, as a combination on the estimations, right? So this is what we have seen, right? If I do the same thing using multiple linear regression using sklearn as well, it's exactly going to work in the same way. Let's quickly check if we did this earlier. I think yes, we did this, right? I think we did this. No, yes, I think we did this. Yes, we did this. We divided the data into training and testing set, and we did apply it, right? So it's actually irrelevant of what library or what package we use. Ultimately, what we need to ensure is that we are trying to create a model which can be explained, right? It can be explained, it can be used. In this case, I'm able to use it. Okay, I can even create this entire implementation that I've done here in form of a Python script, and then that script can be created in a certain way. Let's say that it has a lot of functions. It will have a lot of functions, and each and every function will do each and every job. Like, let's say, scaling of the data will be done by one function. Implementation of the machine learning algorithm will be done by one function. Dividing the data into test and train sets will be done by one function, and so on. And finally, we can have a single main function where we can call the main function. So whenever the program executes, it's going to train the model first, it's going to build it, and then basis the inputs given to the program. Let's say I'm calling the program with the inputs of this, right? The inputs that I have passed is 2, 1, and 1.5, or maybe since we have selected this model, right? So the inputs that I pass is 2 and 1, right? So I call the program and I pass the inputs 2 and 1. If I do that, then it's going to read the command line inputs 2 and 1. Okay, I've got the inputs as 2 and 1. And now it's going to output me the value like this, right? So I'll only input the investments, in this case, investments in radio and TV, right? In the USD 1000 scale, right? And then it is going to give me the final output. So in this way, I can actually try to productionize my machine learning models, where I'm going to convert my implementation as an API. I'm going to convert that as a program. It's just like running your calculator on a desktop, right? So you run your calculator, enter the numbers, give the operand, and it's going to, or you have to provide the operand and the operators. It's going to give you the results. In the same way, I can try to productionize this, right? So we will look at certain things at a later stage, maybe, especially on cloud, because it will be very interesting or very healthy to do such kind of investments or such kind of implementations on cloud, because it's easy in cloud to scale, right? Basis how much data we get, because usually what happens is in any practical setup, we never get an idea, right? Howsoever good our analysis might be, we'll never get an idea how big or how small the data will become. We can only estimate, just like we estimated the value of sales quantity, right? We can only estimate that maybe as of date I have 100 MB of data, tomorrow I might have 150, right? But nobody can be sure. That's where the problem is, because the rate at which the organizations where we are working, the rate of which they are, I mean, we are generating the data, it's really not really predictable right now. So using cloud to deploy the solutions, and then there is one more advantage. I'll not tell you that right now. When we go into the cloud implementations itself, maybe we will discuss it there. So, but there are certain benefits which we'll get while doing it on cloud, because we get many platform as a service, software as a service, where we already have the tools which are really necessary for us to productionize or put the solutions into production, right? Okay, now let's start with what I wanted to do in this class. Is that we have seen until this point in time. Let's write some notes. Okay, so let's write some notes. Until this time, let me just remove this. Until this time, okay, I may have to cut the session short a little bit because I have some other work to attend. So maybe we'll continue for another 10 to 15 minutes, and then we can make it a call, and then we are going to continue tomorrow. I hope it's fine, right? So until this time, what we have seen is that we get the inputs to a regression analysis model in form of numbers, right? We are trying to estimate the numbers, obviously we are, but the inputs that we have seen, if you look at the data set that we've used, advertising data, it's entirely, I mean, all the columns are entirely numeric, right? So we have taken a data set which has only numeric fields. We have not taken a data set. We have not taken a data set as of this point. Sorry, we have not taken a data set as of this point, which contains categorical variables. Okay, so we have not seen what is going to happen if we have, let's say, categorical variables. Let's say in this regression analysis only, the one that we are doing, right? So if we have it's another field, right? It's another field in my data set only, which is giving me the scale, right? It is simply giving me the scale of, let's say, a feature which is scale, right? Or a column which is scale, right? And scale is where I'm going to define how much was the production. So until a certain limit, I'm going to say that it's a large scale, or if it is below a certain limit, I'm going to say it's a small scale, right? Something like this. I mean, that's not a really very good example, but In the data set, what we are going to introduce, let me just take the pen maybe, and that'll be easier to, or to, maybe I can write. So if example, in the advertisement data set, we can take up, or we may have a column which talks about the factory which is producing the item, right? So that's one thing that we can do, or the scale of production for that particular instance, right? So let's say that scale can be considered as, let's say if I have produced a sales quantity which is less than 20, I'm going to call it small, else I'm going to call it large, right? So I can have some kind of, let's say, categorical variable like this in the data, which is often always the case. In our data, it will not always be numeric, right? There will be categorical variables. Now, in such cases, since there are now numeric as well as categorical variables, right? How can we apply regression analysis, right? Regression analysis, I mean, in this case, why is this a question, is because regression analysis can be applied only in case of the numerical data, right? Because, or otherwise, how do you expect me to draw this line? I mean, if I don't have numeric data, then how will I have X and Y? And how am I going to plot them? And how am I going to draw a line? So in any form my data might be, I have to convert it into this numerical form, right? I have to get it into this numerical form. So how do I do that? How can I really do that? Okay, let's clear the drawings. Let's try to see what we can do. Okay, so one very common technique, just a moment. One very common technique which we almost always use is that, let's say I have a data set, something like this, and I have a set of columns C1, C2, and C3. Okay, so I have C3, and here in C3, I have, let's say, categorical variable. Okay, so let's say this variable is like yes, no, answer. So I can take this column, okay, and try to convert it into a numerical form. How can I do that? Is that I can say, yes, I will mark all the y values is equal to 1 and all the no values is equal to 0, right? So in that case, what my column becomes is, I'm going to take all the y, the rows where it is y, I'm going to take it as 1, right? And wherever there is no, I'm going to take it as 0. So it becomes 1 0 1 0 1 0 kind of thing, right? So if I take this, right, if I take this column now, what is the minimum value? It is 0. What is the maximum value? The value is 1, right? So my data is automatically scaled, right? My data is scaled, and I have the data in a very scaled kind of a format, and it is quite good now. Why? Because I can now use the regression analysis on top of this data, right? But imagine what is going to be the problem. But let's try to give it a name. So one way is this, right? So here, what I'm doing, I'm simply taking a character or a value, a particular value, and I'm giving it a label. Okay, so this is not actually the value. Y does not equate to 1. Okay, n does not equate to 0. So this is not a mathematical equation. I'm simply giving it a replacement numeric value, right? So that's why I call this feature, or I call this processing technique, LE, or label encoding. Okay, so I'm taking a label for each and every class of the categorical variable. So categorical variable is like what? It can have classes, right? It can be by class, it can be multi-class, and so on. So in this case, this new column C3 that we have added is actually a by class thing. It has two distinct values, y and n, right? So I'm giving a label to y, which is 1. I'm giving a label to n, which is 0. This is known as label encoding. Okay. Now, if I do label encoding, Okay, is there any problem that you foresee? Usually in practical scenarios, what happens is, if let's say there is a category, let's say now there is a new category C4. Okay, and I have 4 categories. Okay, as part of C4, I have 4 values. Let's say the values are as uh, simple as A, B, C, and D. So this C4 column can have values A, B, C, D. So let's try to do label encoding in this data. Okay. If I do label encoding in this data, let's say I select this as 0, okay, B as 1, C as 2, and D as 3. Right. So I have done the label encoding. So what is going to be my minimum value? In this column, if I create a column out of this data set, I convert this C4 column, which was containing strings, I convert that entirely into numbers, right? If I convert that entirely into numbers, okay, then I get a minimum value of 0. I get a maximum value of 3, right? Is that a good scaling now? Is that a good scaling now? Because earlier I had a good scale, okay, 0 to 1. I know that if I do a standard scaling kind of thing, a regular scaling kind of thing, this range of 0 to 1 is good. Maybe even a range of -1 to 1 is also good, right? I mean, statistically speaking, this is really good because these kind of ranges actually signify something closer to being a normal distribution. But in this case, is this a normal distribution? 0, 1, 2, and 3. Look at the standard deviation. The standard deviation is 1, right? The standard deviation, or it is not exactly 1. I mean, mathematically, if we try to calculate, it will not be 1. But we can assume that it is quite closer to 1, right? But the mean is not equal to 0. If you take a distribution of this, it is not going to be a standard distribution, right? So that's the reason why if I take a categorical variable with more than 2 values and try to do label encoding on top of it, then such kind of problems with data is going to arise. And now the problem here is because I've given it a label, right? I cannot scale it. I've already given it a label. I can't say that now I'm going to take this column C5 maybe. Okay, so let's say this numerical representation of C4 is C5. I can't take the C5 and do a min-max scalar or a standard scalar because this is a label. I'm not supposed to do any mathematical operation on a label because, as I said, this is y equal to 1 and n equal to 0 is not an assignment. It is just a labeling, right? Because I cannot do any scaling, this feature is going to cause problems for me mathematically because I'm unnecessarily increasing the range of the data just to define the classes with labels, right? So this is where another technique comes into picture, which is called one hot encoding. Okay, why is this called one hot encoding? Let's try to understand. If I clear the drawings, I'll take a very simple example: C1, C2. Okay, I have C1 and C2, 2 columns are there. This column already has a numeric value. Let's say this is integer. Okay, and C2 is my character column. Okay, so here is where I have A, B, and C. Let's say 3 values are there, A, B, and C. Instead of creating one column C3, where I'm going to give A a label, B a label, and C a label, what I'm going to do, I'm going to create 3 columns. I'm going to name them as C2 underscore A, C2 underscore B, and C2 underscore C, right? And then what I'm going to do, if in this particular row, or for that matter in any particular row, if I have a value of C2 which is equal to 1, I give a value of 1 to C2A and everything else becomes 0. In the same way, in any row, if value of C2 is B, then I give a value of 1 to C2 underscore B column, everything else becomes 0. And hence finally, I'll have the third column, in this case, equal to this. This form of representation is known as one hot encoding. This is where what you are doing, you are actually creating n number of columns, or I can say p number of columns, where p is the number of distinct classes in the categorical variable which you are trying to convert into a numerical variable. Now you see the advantage in this case. The advantage here is that irrespective of how many values you have, you are always maintaining a scale. Okay, you are back to that same old days where you have a scale of 0 to 1. You're not exceeding that scale. So you have a close to normal distribution. So this is the advantage. So whenever we have any column with more than 2 distinct values, we can break them up in this format. We can add any number of columns, let's say. And the number of columns is going to be, obviously, that will be equal to P, as I said. So P is going to be, let's say, the unique number of classes in the categorical variable C2. And then we can create a data set like this. But if there is an advantage, there's also going to be a disadvantage. The disadvantage is, if let's say this categorical variable has 15 classes, then I'll end up adding 15 columns. If this categorical variable has 25 classes, I'll end up adding 25 extra columns. So this is the disadvantage. It is increasing the size, okay, and only to represent a character data into numerical data, it will horizontally increase the size, right? It's going to horizontally increase the size of my data set or the dimensions of the data set. We have already seen if we have lesser dimensions, it is easy to visualize it. It is easy to calculate it. If I have only one dimension as opposed to my target, it is very easy to do this. If I have n number of, let's say, dimensions, my algorithm becomes slow and slow and slow, or it becomes confused and confused and confused. Right? We will see much more examples complicated than regression, although regression is not also a very easy thing to be ignored like this, but there will be other cases where computational heavy operations will be performed as part of the machine learning implementations. And there, this kind of problems are going to come. If I have like 25 unique values in column C2, then I'll end up having 25 columns, which is not really a good thing, right? So that is really not a good thing to do. So that's why there are pros and cons. I mean, label encoding has its pros and cons. Label encoding is like, it is very simple, right? You can give your own labels using the numbers. You can take libraries which are already available in Python, which gives you the labels. You don't have to create the labels, right? So it is easy, but it is good only in case, it is best only in case if a categorical variable is limited to only 2 distinct values. But the moment you go beyond that, you have to use one hot encoding, and one hot encoding is where you are going to add p number of columns, where p is the number of distinct entries or the distinct classes which you have in the categorical variable. Now, irrespective of the pros and cons, you cannot ignore them. You have to use them. There is no other way. You have to use them. You have to make use of them, right? You have to convert the categorical variable into numerical variable, and then we'll have to work, right? Maybe because of constraint of time, we may have to make it stop here. Let me make a stop here. We are going to continue with practicals by tomorrow. I'll share some links. Yeah, I'll share some links so that you can go through them, so that we can understand what we're trying to do or what we are trying to achieve. Some bits and pieces of the advantages and the disadvantages, the computational ones. I mean, the ones that I've told right now are like the practical ones. Some of the computation ones can be shared. I will be sharing them with you so that you can go through them and try to see in which cases it is going to be useful and in which cases it is not going to be useful. And then by tomorrow, we are going to start with the practicals once more. I hope it's fine, right? Let's make it a call, and we will again continue tomorrow.
Okay. Thank
Thank
you.
you.
Bye bye.
Thank you so much.